it's seeing now, it will record it. It will record the highest value it sees and the lowest value that it sees, and it will lock it into a hold screen. So once you're measuring voltage, you plug this thing onto automatic hold mode or min-max mode, either one, whichever one you have. Then you have this one set up to just measure voltage. You're watching this meter while you're listening to this one, because when this one sees something different and it records a new value, it will beep. As soon as that gas valve is powered, this meter should display a voltage on it, and if it's causing a voltage strain in the system, this meter will suddenly drop in value. But you can't look your eyes in two places at once, so this one will record it for you, and you can go back and look and see something wrong with that stinking gas valve. That's the only way you'll be able to know that. And it will take, I've seen that take multiple trips out to discover that problem.
Is that where the alligator
Yeah, that's where alligator clips come in here. Flip it on, and you sit and watch it.
Also, like a rule of thumb that I was given was like when you show up to a service call and the furnace is on, you have power, but it's not working, it's a mechanical issue. And if you show up and there's no power to it, then it's an electrical issue. Is that good?
I would not agree with that statement. Would not agree with that statement. Because the vast majority of the time, there is power to it, and it's not working. In fact, this brings up another little horse story.
So that would be a mechanical
so it
issue.
would be a mechanical issue then.
No, it's an electrical problem most of the time. Something electrically is probably stopping the circuit from getting to its final destination. I do a troubleshooting class from time to time, and it's all theoretical. It's way up here. And I always ask the group, where do you start on a troubleshooting call? You gotta know who called, no call. What's the very first thing you do?
Thermostat?
And I always get answers from people, which is ironic because there's no straight answer for this question. But a lot of people have an answer. I always do this. I always do this. And invariably, somebody in the room would say, I always check the power supply first. And I had this one guy, he was like, check the power supply. Oh, really? You always check the power supply? Yep, always check the power supply. Why do you do that? That's how I was taught. Who told you that? And then from then on, the more specifics about it kind of started to go away. So we start challenging the idea to find out if it's a really good idea or not. The defense for that idea starts to kind of waver. Like, okay, notice that. So let me ask you then, and you still holding by it, man, you got to check the power supply first every single time. Of all the times that you've gone to check the power supply first, how many of those times was that actually the cause of the problem?
Very little.
Nah. Who's going around turning all these power supplies off on you? Normally, that's not the place to start. We'll talk about where the place to start is as we go through more of our troubleshooting stuff. I don't think we're going to get there today. We're going to get some more basics covered. But be aware, there is no definite answer. I always start at this place every single time. It's a waste of time. Now, if you don't know anything else to do, this is a starting point. Yes, for somewhere. That's fine. But when you get better at this and you get more skills, you're more concerned with getting the answer as quickly as possible and as accurately as possible so that you can dig underneath it to find out what caused it. That's not necessarily the best way to go.
It's like what Joe was saying though too. The first thing you check the thermostat because the thermostat's not communicating to your furnace. It's not going to just turn on. So that's the reason why we check the thermostat first because, like you were saying, big power, you're really issue.
Yep. It's also a pain in the butt. I'm all about easy, man. It's the easy thing. Very good. Did you turn it on? Are you sure? Yeah. Did you try turning it off and back on?
Yeah.
All right, so we measured voltage here, we measured voltage here. Now we're going to do another voltage measurement. I want you to go from L1 terminal with power on to the metal case of this power switch. Or any other metal case of anywhere else on the board. From the L1 terminal to a metal surface.
124.
125.
You get pretty much what you measured from step 1, right?
Yep.
Now measure from N to a metal case. Zero. What we just did is we verified, first of all, we have ground. What we noticed, remember that voltages are measuring a difference between 2 points. the representation of the potential for current to flow between those 2 points. That's what you're measuring. Everybody hear that? Eyes up here. I see some guys looking around. When you measure voltage, you are measuring the potential for current to flow from the point where your red lead is to the point where your black lead is. Did I say you're measuring the presence or absence of voltage? No. Point A to point B, you're measuring the potential for current to flow between those 2 points. Yes, there is such a thing as a presence or absence of voltage, but when we are measuring voltage in a service troubleshooting situation, what we really want to know is what is the potential for current to flow between this place and this place. That's what we need to know. Is it a very high potential or no potential? Does that make sense? Understand why I'm making that very subtle but important distinction. I'm not being a dick about it. That's on purpose. Because there's a difference between having voltage there and actually having the potential for current to flow. Let me explain it this way. And we'll measure this in just a little bit. Power line. Right? Power pole. I don't know. I can't drive this in the power pole. Not an art. 20,000 volts on this power line. And you may not be aware of this, but your high voltage power lines are like way up in the air. There's no insulation on that wire. They're bare. We got a bird. Dinosaur bird. Sitting on one of these wires, this is 20,000 volts of electricity. Bird is completely unharmed. You ever wonder why that was? You a squirrel hopping on a line, squirrel's completely unharmed. You were taught as a kid, don't ever touch a power line, it'll kill you. How come the squirrel has supernatural powers? It's not getting killed. Why?
Because it's touching the top of the side.
The squirrels are from the devil.
Between these 2 points, there is no difference in voltage potential. There's no possibility for current to flow between those 2 points because there's no difference in voltage there. If I were to take a meter and measure between these 2 points, I would get 0 volts. For all you and I know, we could be living in a highly charged, multi-billion volt environment and never know it because there's no difference from point A to point B. Current only flows once where there's a difference between the 2 points. Then we get current moving. Current is the thing that kills you. Now, if this bird were to happen to stretch his beak over and touch that line, yeah, now he's a crispy critter.
Fried chicken.
Poof,
Yeah,
fried chicken. Yeah.
So you're saying if Drew's naked, he could tightrope across a high power line with no problem?
He could do it if he had clothes on too.
Preferably clothes on.
Now, I don't know about this tightrope blocking ability. That would really be the determining factor right there.
I'd probably be better without any clothes on. Or aerodynamic. Brown skiers.
I don't know, as long as there weren't any pretty girls walking by and they'd get all off balance. That's not even bouncing right, it's off balance. So, we measured the resistance of our switch, right? Alright, I think we've done the experiments that we want to do. Oh no, there's one more yet. So we measured from L1 to ground and from neutral to ground, right?
Yes.
And what we determined is that there is no potential difference between N and ground, right? In an electrical circuit, electricians speak means that the neutral wire is what is known as a grounded conductor. It is referenced and connected to ground. Therefore, there is no potential difference between the two. Therefore, for us as mechanics, we might think there is no difference between the neutral wire and the ground wire. And that is a very dangerous assumption to make. That is actually very incorrect. And I've seen a lot of things that were wired that way that are just plain stinking wrong. The ground wire is that green one that you see stretched across from the left side to the right side. It's also connected to the little middle round plug of the power cord. That's the grounding conductor. That ultimately passes through the wiring of the building back to the panel, out of the panel, physically to the earth itself. All voltages are ultimately referenced to the voltage potential of the earth, also known as the ground. That's why it's called ground. In the olden days, there used to be an 8-foot copper stake driven straight down into the earth, and that's what the ground reference point was. It was physically the earth. We call it an earth ground. Then to improve upon that, we call what's called a 3-point ground, which is copper stake in the ground connected to metal gas line, which goes into the ground, also connected to the copper water line, which goes into the ground. Well, modern technology now, we have plastic gas lines, we have PEX water lines and plastic water lines. They're not grounded anymore. They're not conductors. And that stake that goes into the ground would ultimately corrode, or the ground would get dry, and there wouldn't be very good conductivity there. So now we have another grounding point called a UFER. Sounds like it's from Michigan or Canada, a UFER. A UFER is an acronym for some other name I can't remember, but basically that is the reinforcing steel in the foundation of the building with a little tab sticking out, and that's where they attach the ground. So now the ground is the whole foundation of the structure, called UFER.
How long have they been doing that?
All decades. I don't know exactly how long, but at least 20 years. Now it's standard. So the neutral wire is ultimately grounded. But in our circuit, only 2 conductors are carrying current. There's the hot line, the neutral line, and that's it. The neutral line is a current carrying conductor which is referenced to ground. It's sharing the potential with ground. Ground is not carrying current. If any current goes to ground, that's a fault, isn't it? Ground is supposed to be a low resistance path for current to flow to the earth. Low resistance path for current to flow. So if on this electrical apparatus these metal switch housings, which are things that people can physically touch and interact with, if a hot line were to touch one of those, and I were to come up and touch it, I am going to be the path to ground. A fairly high resistance path to ground, which means heat. Electric shock, bad deal. So the ground wire is there to provide an alternate low resistance path to ground, so that if the hot line touches this metal cabinet, it will take all of that current it can possibly get and direct it to ground, which is going to cause the circuit to overload and ultimately shut off. It's there for safety. When you're working on electric motors specifically, that little green wire or that little green nut, which is very easy to ignore because it's a pain in the butt. A lot of times you cut the stupid thing off to get the motor out, and the new one is, it won't fit where it should. Hell, it doesn't need that to run, right? It needs that so that people don't die. So don't ignore the ground wire. Very critical. You've got to connect the ground wire, and it's got to be there correctly. Also, if you are trying to wire up a new circuit and you say to yourself, shoot, I don't have a neutral wire, but I got this ground wire, I can run it off of that. No. Sure.
Back home, they still do a lot of sun coolers,
Yeah.
and that is a big issue where they get the nutrient. You can put your meter to the water, and you'll get voltage.
Yeah.
And yeah, it's dangerous.
Yeah. I remember one time I was working on a unit heater in somebody's garage. Grab it.
Yeah.
Same thing on the ground.
This is usually does 3 ground rods
3 ground rods.
Yeah.
in a triangle shape.
That might be an alternate or an addition to the UFER.
Oh, 'cause a lot of houses down there are basements.
It's in the foundation, yeah. It's in the concrete, reinforcing steel and concrete in the foundation. All right, gentlemen, let's unplug all your boards. There's a couple more lesson stuff I want to go through, so go back to your original seats, and then we'll wire up some circuits on here.
John, you fucking fired. Good shit, fucking go home.